Table 17 shows the pKa value for two acids, propanoic acid 4.87, butanoic acid 4.82. First of all, I've got to convert pKa into Ka so I can make sense of those numbers. So pKa equals minus log of 10 of Ka, so pKa equals minus log to the base 10 of Ka. So these values, the pKa for propanoic acid 4.87 equals minus log to the base 10 of Ka. You've got to get rid of the minus sign first of all, so make both sides minus, and minus 4.89 equals positive log 10 Ka. Then you can get rid of the log by doing inverse log or shift log on your calculator. So inverse log or shift log of minus 4.87 equals 1.35 times 10 to the minus 5. So that's the Ka of propanoic acid. You do the same thing but for 4.82 for butanoic acid, and it works out as 1.51 times 10 to the minus 5. So now I've got the Ka as the acid dissociation constant or the equilibrium constant for these two acids. The larger it is, the stronger the acid, because remember, a Ka, or an equilibrium constant, is the concentrations of the reactants multiplied together on the right hand side, the products that we're making, divided by the concentrations of the reactants on the left hand side. So the more products we make, the larger the number, the larger the Ka, the larger the dissociation constant, and the more products we mean, the more it's dissociated as an acid and the more H plus it's made. So the larger the number, the larger the Ka, the stronger the acid. So butanoic acid is the larger answer, is the larger number, and butanoic acid is the stronger acid. So the value of Ka for propanoic acid is 1.35 times 10 to the minus 5. That's correct. The answer is C. Which element is in the F block of the periodic table? So you've got to find the F block, which is at the very bottom of the periodic table, and you'll find that plutonium is in that bottom block called the F block. So that's just identifying plutonium in the F block at the very bottom of the table from your copy of the periodic table. Answer D.